A question like this would give you a graph and it would say something like, find the equation of this curve, what is the equation of this function, or something like that. In other words, here's a graph, what is the function? These questions, in my experience, tend to be really poorly done. They're generally done okay if it's a parabolic graph, so a quadratic function, but when you move up to some other type of polynomial, like a cubic in this case, they tend to be poorly done, and they tend to be poorly done because students don't remember the general formula. So the general formula for a cubic function, now remember that a cubic function is one that contains an x cubed term if it contains some other highest power term, like a power of 4, that would be a quartic, a power of 5 is a quintic, and they just keep going like that. But let's focus on the cubic case, although this would be applicable to other cases as well. In the case of a cubic, the general form is going to be some k value in front, which is a coefficient value, multiplied to 3 brackets. So when you factorize a polynomial function, the order, which is the power, the highest power, dictates how many brackets you should get. So a cubic, being a power of 3, should have 3 brackets. So the general form is going to be something like this. 3 brackets, potentially some number in front, which is often a 1, but it can be something else. But the other important point is that each of these brackets, each of these factors, relates to one of the roots. And essentially the a, b, and c value reflect the root points on the graph. And that's always true for polynomial functions in their factorized form. Just like if you had 2 brackets, you would know that these two numbers, the b and the c, relate to the 2 root points. So it's the same with a cubic function. But in the case of a cubic, it does potentially get a little bit trickier because I'm claiming that there are going to be 3 brackets, but we can see here that there are actually only, well, there are 3 brackets, but there are only 2 roots. And I'm claiming that each bracket connects with one of the roots. So it kind of does, but there's a little twist to it. And the twist is the thing that often gets students a little confused. So we can see we've got a root at -1 and a root at +2. So the -1 root just needs to have a factor that goes with that. So if it's a -1 root, it's going to be an x plus 1 factor. And if it's a +2 root, it has to be an x -2 factor, because the sign in the factor inside the bracket is always the opposite to how it is on the root. And that's because if you were to put a 0 there for y and then solve that equation, you would be flipping the sign on the other side. So we've only used 2 of our brackets, and this is how you will, by the way, start these questions, by knowing the formula, associating the roots to the factors, just to fill in the values. But notice that we should theoretically have a 3rd bracket. We don't have that. That's because this root here is also a turning point. If you've got a root which is also a turning point, which is a super common scenario in this type of question to try to test the student's knowledge a little bit more, then essentially what happens there, that factor gets repeated like this, okay? Or you could write it with a bracket once with a squared on it, that's fine as well. So either that form, or probably more commonly would be this form, just to write that bracket one time and put a squared on it. So it's still the case that we're associating the roots to the factors, but if it's a turning point also, you need to repeat that factor. Usually there'll be another point given in these questions. In this case, it's a y-intercept point. It doesn't have to be the y-intercept, it could be any point, but this additional point is for finding the k value. So that point there at -8, just remember the full coordinate of that point is 0, -8. So 0 is the x value and -8 is the y value. If we substitute those into the equation, we get -8, k is just k, x is going to be 0, so that's going to be 0 plus 1, and then 0 minus 2, and essentially we've now made a little equation, and if we solve that equation, we'll get our k value. So let's just quickly develop that. So k can just stay in front, 0 plus 1 is just 1, 0 minus 2 is -2 squared, keeping the -8 there, -2 squared is +4, times 1 is still +4, times k is going to be 4k, so that gives us a k value of -2. So the additional point you get in these is nothing to do with, it's not a root point, so it's nothing to do with the factors, it's just to do with finding the k value. So then we could go back to this point here and just finally say that the equation is -2 for the k value, x plus 1 for the first factor, and then x minus 2 squared, repeated factor, for that turning point root. So that's how you find the equation of a cubic function from its graph.